Welcome back. So today is part 2 of the CAST rule lesson, right? Today we're going to be mostly focusing on calculator-based questions. And having said that, our very first question is going to be using, it's a non-calculator question, but that's just like a segue, right? Quick recap. Yesterday we looked at the CAST rule where we said that all sine, cos, and tan are positive in the first quadrant, right? And only sine is positive in the second quadrant. Only tan is positive in the third quadrant. And only cos is positive in the fourth quadrant. Okay, so we have the 4 quadrants. We have the CAST rule, and that just tells you whether sine, cos, and tan are positive or negative in each of those quadrants, okay? Now, for the very first example, it's pretty straightforward, right? We're not doing anything too much new over here. It's just like a segue into the next question, okay? Except we're not using special triangles, okay? For the angle 110 degrees in standard position. So for the standard position for 100 degrees, right? We know that this is 0 degrees, that's 90 degrees, and this is 180 degrees. So 110 should be somewhere over here, okay? Again, you're not graphing to scale, you're just sketching it, okay? So that's in standard position. Start with the positive x-axis, and then you go counterclockwise. And so that is positive 110 degrees, and that is theta, okay? So we've done that. Okay, so when they say sketch the principal angle, that's all you've got to do. Done. Determine the related acute angle alpha. For that, we need to drop a perpendicular to the x-axis. Okay, so the perpendicular goes to the x-axis always, never to the y-axis. So this is 90 degrees. And we need to find this related acute angle here, right? This related acute angle here, alpha. And they want you to find alpha. And it's just not very difficult to do. All you need to do is say, well, wait a minute, I know that's going to be 180 degrees. So alpha is 180 degrees. Take away 110 degrees. What is that? 70 degrees. Okay. Done. The third part, state. Okay, now when they say state, they're not asking for justification, explanation, any working out. So just state. State whether tan 110 is positive or negative without using a calculator. So all we're going to do is fall back on the CAST rule. Okay, so that is all. Only sine is positive here, only tan is positive here, and only cos is positive here. Since we are in the second quadrant, okay, the terminal arm is in the second quadrant. Okay, only sine is positive, and therefore tan is going to be negative. Tan 110 is negative as the terminal arm. You don't even have to write all of this, these details. All you have to say is positive or negative, okay? As the terminal arm is in the second quadrant. Okay, I've gone a little beyond state. When they say state, you don't have to give any reasons. Right, moving on to the next question. Okay, this question has 4 parts. So that's question example 2, part 1 and 2, and then 3 and 4 is on the next page, right? Just for saving space and reducing clutter, I've broken it into 2 pieces. Now the point -83 is on the terminal arm of the angle theta in the standard position. Okay, now that's a lot to process, okay? First of all, there's a point, -83. And where's this point? It's on the terminal arm. The terminal arm of the angle theta in the standard position. Okay, so we're going to draw a terminal arm, but where are we drawing the terminal arm? In which quadrant? It should be in the second quadrant, right? Because negative 8, 3 should be in the second quadrant. Okay, because x is negative and y is positive. Okay, so we're going to drop a perpendicular here, right? So we have P negative 8, 3. Okay, this is the x value, and this is the y value. Okay, so we're going to mark that here in the diagram. So this is x value is negative 8, and the y value is positive 3. Okay, oh, well, they only wanted us to sketch the principal angle. So there we go. That's the principal angle. Okay, and this is the point, P negative 8, 3. Okay, we actually didn't even need to draw all this part. Okay, none of this was necessary. All right, they just wanted us to draw the principal angle theta. And so that's all you need to do is figure out which quadrant and draw, sketch the principal arm. Determine the value of r to the nearest hundredth. How do we find r? What is r? Okay, so this terminal arm can keep going on, right? But r value is just this, this bit over here. Okay, so from here to here, that is r. Okay, so how do we find r? Let's just use Pythagoras theorem. Okay, which is negative 8 square plus 3 square under root. Negative 8 square is 64 plus 9. So that should be root of 73. And that is an exact value, right? You could leave it like that if they didn't say anything, but they asked you to the nearest hundredth, right? So we have to put that into the calculator and get it up to the second decimal place. That's what the nearest hundredth is, right? So square root of 73 gives me 8.54. Okay. Or 3 significant digits in this case. Yeah, so that is the value of r. All right. Part 3 of this question. Determine the primary trigonometric ratios for angle theta. Now, this might be a little confusing for some of you because you might say, well, what exactly do they want? Okay, do they actually want decimal values? Do they want like an actual ratio? I'm going to go with the fact that they might be wanting a ratio. Okay, they say primary trigonometric ratio. So x was negative 8, y value was 3, and r was root 73. Okay, we have a decimal value, but since I remember this value, I'm just going to write it, the exact value, I'm writing it as root 73. All right, and this is theta. So, and this is alpha. Okay, so this is alpha. To find the primary trigonometric ratios, we fall back on part 1 of the lesson, right? Which is sine theta is the same as sine alpha, except now you have to introduce the positive and negative signs. Okay, so that is going to be 3 over root 73. Okay, by now you should kind of know that this is the opposite side. Okay, and this is the hypotenuse. Okay. What about cos theta? And sine theta is positive. Okay, see how 3 is positive and root 73 is positive, and by cast rule, the second quadrant, it should be positive. Right, let's go on to figure out what cos theta would be. right? Cos theta is adjacent over hypotenuse, so that should be -8 over root 73, okay? Cos, as expected, is negative in the second quadrant, okay? Only sine is positive in the second quadrant. And tan of theta is opposite over adjacent, so 3 over -8. We normally don't leave negatives in the denominator, so you could write it as tan theta is -3 over 8, okay? Or you could write it as bring the negative right to the numerator, okay? So there we go. That is sine, cos, and tan theta, which are also called the primary trigonometric ratios, okay? So we use alpha to find the primary trigonometric ratios for theta. Calculate the value of theta to the nearest tenth. Now I could use any of these values. I could use sine, cos, or tan, okay? So for the fourth part, there's no preference, okay? Use sine theta or cos theta or tan theta, okay? Specifically, sine inverse of that, the numerical value on the right side of the equation. So I'm just going to use theta, okay? So I'm going to say for question 4, I'm going to say theta is tan inverse of -3 over 8. Type that into the calculator. Okay, you're going to end up with 20.556 okay, or rounded to 3 significant figures, it'll be 20.6. Okay, make sure your calculator is in degrees, right? We're working in degrees here. So that's the second example. The third one is very similar to example 2. So you can pause the video when I move on to example 3 and try it out, and then you can double check if you're on the right track, right? So again, question 3 has 2 parts. We have part 1 and 2 here, and part 3 and 4 on the next page. Okay, feel free to pause the video at this point and actually sketch the point and the point on the terminal arm and the angle in the standard position, right? So P6 -8. This is the X value, and that's the Y value. And that has to be in the fourth quadrant, so I'm going to draw that this way. Okay. Always drop your perpendicular to the X-axis. The X value here is 6. The Y value is -8, okay? Because this is along the X-axis, so that is 6, okay? This is along the Y-axis, and that is -8. The R value, okay, that's your radial arm from here to here, okay? We also need to find the radial arm, but so that I'm running ahead of myself. All they asked is to sketch the principal axis, so the principal angle, okay? So this is the principal angle. All the way from here to here is the principal angle theta, okay? I don't think I did that correctly. There we go. All the way from the positive x-axis. Okay, so that is your principal angle, okay? And this is our point. That's the point, P6 -8, okay? Okay, so this is 6, okay, and the other is -8. Determine the value of R to the nearest 100th. Same story. Pythagoras theorem. 6 square plus negative 8 square, 36 plus 64. I believe that is root of 100, which is 10 to the nearest 100th. All right, so that's just it. Well, technically to the nearest 100 would be 10.00, okay? Right, so we're done with the first and the second part. Let's move on to the third part. Determine the primary trigonometric ratios for the angle theta. Okay, so we had the terminal arm here. We had a point P 6, negative 8 here. We dropped the perpendicular to the x-axis. We know that this is negative 8. We know that's 6, and we know that this is 10. Yeah, and the primary trigonometric ratios, we're just giving out the ratios. We're not really calculating it in decimal form. So sine theta is negative 8 over 10. That's opposite over hypotenuse. And sine should be negative in the fourth quadrant. Only cosine should be positive. And cos theta, actually, you can also simplify this and write it as sine theta is negative 4 over 5. Okay. Cos theta is adjacent over hypotenuse, so that is 6 over 10. Okay, you can write that as cos theta is 3 over 5. And tan theta is opposite over adjacent, so negative 8 over 6. From there, we can write tan theta is negative 4 over 3. Okay, so we have our primary trigonometric ratio set up. For the fourth part, calculate the value of theta to the nearest tenth. Okay, I'm going to use tan inverse of negative 4 over 3. Okay, so theta is tan inverse of negative 4 over 3. Plug that into your calculator. Okay, actually do that. So tan inverse, we are working in degrees. You end up with theta equals negative 53.13. Okay, now that doesn't seem to make sense. Why? Because negative 53.13 is this angle. Okay, that is negative 53, right? So that's that angle. Let's show this over here. Okay, so this is negative 53.13 degrees. Well, what we actually after is the principal angle all the way going from here to here. Okay, so that is 360. Okay, from there. So this is not the full answer, even though that's what your calculator gave you. We're almost there, but not quite. So we have to do 360 minus 53.13. Okay, sorry, I'm seriously running out of space here. Okay, maybe I should have gone. Let's try to move everything over to here. Okay, so from here, going over there. Okay, theta is 360 degrees. Take away 53.13, and that is sorry, my calculator. I just typed something incorrect on my calculator. Bear with me a second. All right, 360 take away 53.13. And that is 306.87. Okay, or you could round it to 3 significant digits and say is 307 degrees. Okay. Okay, so that is your answer. Okay, in 3 significant figures. All right, on to the next example. Well, the analysis on this question is far simpler than the previous 2 questions. Okay, so hopefully we get through this a little quicker. Given that tan theta is all of this value, 2.74 and so on, find all values of theta given that theta is in the domain between 0 and 360. Okay, maybe I should do that. In this question, it doesn't matter, but in some questions, having the equality on and on the inequality sign is important. Okay, for now, it doesn't make a difference for this question. Right, find all values of theta given that the domain for theta is between 0 and 360. So 0 to 360, 0, 90, 180, 270, and 360, which means you're going to scan this entire domain, okay, between 0 and 360. So that's what that means. Scan the entire domain and find solutions everywhere in that domain, okay? Now, tan theta is positive where? Right, this is all sine, cos, and tan are positive. So that means tan is definitely positive here, which means I'm going to put a terminal arm there. Okay, so tan theta is positive in the first and third quadrant. Okay, this is sine is positive here, tan is positive here, and cosine is positive here. So I'm going to draw a terminal arm in the first quadrant and the third quadrant. Okay. So to find the angles, right, you're looking for all the angles. This is my very first solution, okay? So I'm just going to call this theta 1 for clarity. I'm going to call the second solution going all the way from here until it hits the terminal arm as theta 2. So there are 2 possible solutions as we go around the whole domain 0 to 360, looking for where tan theta is positive. It's positive in the first and the third quadrant, so we have terminal arms there, which means there are 2 possible solutions labeled as theta 1 and theta 2. So normally, I would have to just type that into the calculator. Theta is tan inverse of 2.74. Okay, just type the whole thing in, grab your calculators. So second tan inverse 2.747477, and that is 69.999. So I'm just going to round that to 70 degrees. Okay, that's my very first solution, okay? If this is 70 degrees, okay, this has also got to be 70 degrees. And why is that? Why should both angles be 70 degrees? It should be the same because they're giving me the same ratio for tan. Opposite over hypotenuse, opposite over adjacent is the same in both triangles. That means that the tan theta is the same in both triangles. And therefore the acute angle theta or alpha should be the same, okay? So the acute angle is the same in both, okay? So that is my first solution, theta 1. The second solution, theta 2, is, so this is 180 degrees, right? So 180 degrees plus that value. So 180 degrees plus 70 degrees. What does that give me? 250 degrees, right? So you have two possible solutions at 70 and 250. Okay? So your final answer, just put it in a square bracket here or in a box. Okay, so theta 70 degrees or 250 degrees. Okay, so we get this using a calculator. Yeah, after that, we have to analyze to figure out where the next solution is. Even though this is a calculator-based question, it doesn't give you both solutions. You have to figure out where the next solution is. Okay, right. Off to the next example, which is very similar to example 4. Feel free to pause the video, right, and try it out on your own, and then you can check on your check whether you're on the right track. Now, cos theta is all of this, right? That's what's given. Okay, so you say cos theta is negative where? So all sine, cos, and tan are positive here. Only sine is positive, which means cos has got to be negative. So right off the bat, I'm going to put a terminal arm there. Tan is positive, which means cos has got to be negative. Cos is positive here. Cos is negative in the second and third quadrant. Okay, so what does that mean? That means you have the terminal arms in the second and the third quadrant. That's all it means. Okay. And if cos theta is the same for both triangles, so both terminal arms give you the exact same value for cos theta, that means their sides are all exactly the same, right? Or the same ratio, right? So we have adjacent over hypotenuse for one triangle and the other triangle being the same. So the first solution is going to be over here. Okay, so this is my very first solution. Call it theta 1. Again, we're looking for the whole domain 0 to 360, right? So we have to go and look for another possible solution within that entire domain. The next possible solution is over here. You call it theta 2. Okay. So now to find that, I'm just going to do theta is cos inverse of negative 0.92, whatever number is given. Plug that into your calculator. Okay, grab your calculators. And cos inverse of negative 0.9205 048. I got 156.9999. I'm going to round that to 157 degrees. Okay, so that is my very first answer. But that's not going to be very helpful. You cannot just add something onto a 180 to get theta 2. I need to find the related acute angle here. Okay, I need to find this related acute angle here. And how do I find alpha? Alpha is 180, take away 156.999, which is 157, which is 23 degrees. Okay. Then we're going to link that to the next part to give therefore theta 2 is 180 plus 23, which is 203 degrees. Okay. So your final answer So your final answer is going to be this. Theta is 157 degrees or 203 degrees, two positive solutions. And that concludes part 2 of the CAST rule lesson. Go and try out your homework. All right, so that's your homework for today. And it's very similar to everything we've done in class. All right, have a good day. Bye-bye.